Each of these look like they can do the job of drawing filament, but how well can they really do it, and what does it look like when we use a thermal camera? We're going to compare these three to find out what is really going on so you know what to expect and you know what to look for if you are in the market for a filament dryer. So stick around. I want to say thanks to everyone who has subscribed. We've now passed the 80,000 subscriber mark and we're well on the way to that 100,000 goal by the end of the year. I still remember just starting out and thinking that having 22 subscribers was pretty cool. We're just a little bit further along than that now. I've had a lot of comments on my poor face lighting, so I'm upgrading it. That is the lighting. I can't do much about my face, and hopefully there's a big improvement in my upcoming videos, so thank you for the feedback on that. So when you want to buy a product, it has to look good, I know that, but most importantly, it has to function properly. This one here has a vent in the top and it pulls air in from the bottom, so the humid air has somewhere to go. For these two, that is not so much the case. I don't really know how well these function because the humid air doesn't really have a good place to leave. So how do these two dry the filament just as well as this one? And are these really just meant to look good and they don't function quite as well? Or is there more to it than just that? First thing we're going to do is try and open each of these up to see what's going on the inside. So let's take a quick look at this one before we take it apart. So it has lots of holes to choose from. That's a pretty good thing, but I do find that when I try and use the holes in the top, the PTFE tubing slides through these rubber grommets and it wants to meet directly up against that spool of filament, and I don't think that that's a good idea. So I tend to only use the holes on the front and on the back. That seems to avoid the problem. Now this does have this dial that's embedded near the top, and when I received this, it was covered up at the very top. And I think they covered it up because this temperature and this temperature readout are nothing close to the same, which then makes me wonder if this is a relative humidity, how can this humidity be accurate? Take off the acrylic case and you can see in the top we have the ventilation. And of course, these holes also act as a vent as well. So because I've used this for so long, there is a little bit of wear and tear. Here we have a little bit of melting that's happened in the center. So it's overheated. This base really should have been made from glass fiber reinforced nylon, and the rollers are a little bit loud. The bearings are probably losing all their grease, but they still work. They're just a little bit noisy. And the other issue is that the base is actually sunken down in the center. It's sagged down. So the spools tend to want to meet or come closer towards the center. They still work. They still roll. I think that there's just a little bit too much friction there. Loading filament into this thing, especially two spools if you're feeding two printers, is a little bit annoying. Once you get used to it, it's not too bad, but I do find that when you're putting the lid on, you need to pull the spools of filament as well to make sure that it doesn't come out and around the outside of the spool. All right, so this is a very basic setup. We have the fan that's able to draw in cooler air, which is less humid from the bottom. Everything looks in pretty good shape as far as the electronics go. There really is not much going on the inside here. Well, the fan isn't too dusty and it doesn't look to be melted at all either, so that's a good sign. It is working properly. And they have this little cover on the fan as well, supposed to prevent any debris from below getting sucked into the fan. Let's go ahead and turn this thing on. And this is pretty loud. It comes in at 44 dB with the cover on. Just shy of 44 dB. One of my main issues with this is that it takes so long to turn off. I just pressed it and it takes about a minute for it to turn off. My guess is because they want that fan to cool the heater off enough so that it doesn't melt anything. It could be that that's one of the reasons that this is kind of melted up here. If I turn this off and I unplug it, that heater could very well melt that plastic. So let's move on to the next one. So the Sunlu S2. It's pretty nice, fairly compact. I know some people have complained a little bit about it's not very stable. So these legs really should have been out a little bit further. It does have little rubber pieces on the bottom. And if we look inside, the heating elements are quite a bit different from anything else. This wraps continuously around the filament. So that's a very neat approach. And it looks to me like there isn't a safety issue if you ever did touch any of these elements, that they are all sealed up. I found this one pretty easy to load the filament. You can see that, and because there we go. Because you don't have to hold on to the lid, it's far easier to load the filament in. And the same goes for unloading. Now, one of the issues that I found with this is that the rollers on the inside are a little bit too close together. And when the spool becomes lighter, there's not enough to hold this in place, and it can twist and get jammed. And it doesn't want to spin very easily. So those rollers on the inside really should have been spaced further apart. Now, one thing that you can do to help with that is to put one of these inside the center of the spool to keep the weight up. You can also just get a little piece of steel, a chunk of steel, and put that on the inside as well when it rolls around. So let's open this one up and see what's inside, because it is nothing like the other ones. All right, so we have a very, very small fan, and there is a little bit of fan noise from this one, but this one is actually quite a bit quieter than the other ones, and I'll check that out in a minute. Let's open up the inside and see what that looks like. So these are the rollers, and I found that they're very quiet. And they seem to roll with very little friction as well, which is kind of nice. All right, so there is very little to this. We have an aluminum plate here, and on one side of the aluminum plate we have the heating element. And then down below we have that single, very small fan. And the funny thing is, the fan is drawing air in from just below the heating element. I'm not 100% certain, but it looks to me like this fan really is not intended for air circulation as much as it is intended for making sure that the electronics section doesn't overheat, or at least all of the wires leading to the electronics. Let's turn this on. Wow, the amount of air movement is almost non-existent with this fan. I could barely even feel any air moving at all. If there is any air movement, it's very, very minimal on the inside, but it is being directed towards the wires which lead up to the display. So loading filament in and out, pretty easy. The one complaint that some people have made is that the display is on the side, which is in the width. Most people like to store them this way, and if they're stored that way, and then maybe the printer is beside it, they can't see what's going on. So in my case, when I was using it, I had it up on top of the 3D printer and I had it turned this way, and that worked really well for me. I kind of like what they've done with this. I like the display. It's very responsive. It has a lot of features on there as well. It also has the little LED light, and this one is pretty quiet. On the other hand, it unfortunately is lacking air circulation, or enough air circulation around the filament. And if you don't have air circulation, it's probably not going to be able to pick up as much moisture as maybe some of the other filament dryers. As far as noise levels, this one comes in at around 36.2 dB on average, so it is pretty quiet compared to the other one. All right, let's have a look at the Creality. So like the Sunlu, it doesn't have any additional ventilation other than this one tiny little hole in the top. And I'm not sure if you could call this a vent, because this is where the filament has to pass through. So if you're printing while it's trying to dry, it's going to block that hole quite a bit as well. This one opens up backwards. So the loading is a little bit more difficult on this one, I find, because typically you're going to load it from the front. And they have this darkened display here, which I find makes it a little bit more difficult to see inside. There we go. This one, unlike the Sunlu, does have a fan below, which is purpose-built just to circulate the air. So this one has more like a supply and a return area. The rollers on this one are spaced a little bit further apart than the Sunlu, so it doesn't seem to wobble around like that one does. Definitely more stable than the Sunlu, just barely. And the rollers are pretty quiet, and they seem to roll without very much friction at all. I really want to have a look inside, but I'm just noticing that it looks like they've made part of this out of glass fiber reinforced or something a little bit more heat resistant, and then there's a little bit different plastic up here. So I don't know how to take this apart, but my guess is that I need to take these 4 little feet off in order to unscrew the base. So let me try that. Well, I was not able to get this apart. I don't know exactly how this is connected, but unfortunately as I bend this, it's doing something funny with the screen. So I don't want to take it any further than that, but I can let you see what's inside there. And I think they actually have some pictures on their website as well. I can probably show right now. But on this side, you can see the heating element right inside there. And on the inside, there's a pretty good sized fan as well, which is blowing directly into that heating element. Everything on the inside looks pretty clean and pretty well built. Because of the way they designed the base, and the center of gravity is pretty low as well, this thing here does not want to tip over very easily. Okay, so let's have a look at this fan and how well this thing blows. It's going to sound a little bit noisier as well. I've got the cover taken off too. There's a lot of air movement coming out of this one with that blower fan. So this one is in the range of the first filament dryer that I showed you. It's about 44, a little over 44 decibels. You can hear that here, it's quite loud. If I put the cover on, it's not quite as loud, but there is that kind of high pitched. The other ones don't have that noise, so it must just be the fan that they've chosen to use in here. This one works quite a bit different than the others because this is the supply of hot air. It circulates around, comes into the return, and hopefully a little bit of air also comes around the bottom as well. So this one has a pretty responsive display. Lots of features as well. You can adjust your temperature, you can quickly adjust your material, and you can adjust your time as well. If you go down, you can go up to as many as 48 hours on this unit. I also find that the humidity is very responsive on this compared to some of the other ones. It seems to change very rapidly, especially if you open this up. I'm going to get the thermal camera on these in just a minute, and I am preheating these, and I noticed that the Creality almost instantaneously got to 65°C. I started at 5 hours and we are at 4 hours and 53 minutes. And you can see if I open the top, it's going to lose heat really quickly. We'll see how quickly it climbs back up. Okay, it's already done. That didn't take very long at all. This one here, on the other hand, it hasn't even reached the maximum temperature yet. It's quite a ways off still. This one, I don't think we're ever going to be able to get to 65. So finally, I'm going to call it. It's pretty much there. We are about a half an hour to get to temperature. We're within just a few minutes for this one. And, well, this one, little by little, is creeping up. We're at 43 degrees now. So, hey, maybe after a couple hours it'll be up to the 65 number. Probably not. I have all 3 filament dryers turned on, and I have some filament loaded into this one. I'm going to use the exact same spool of filament in each one, which is the same color, and also has the same amount of filament on the spool so that we get the most accurate test. So I want to use the thermal camera to get a sense of where the heat spots are, where the temperatures are the highest, and how well it's heating, if it's uniform or not. So Thermal Master sent this to me, this little cool device, and this plugs into USB-C. This is for Android, and the app starts automatically. And now we can use our phone as a thermal camera, and we can even record. And you can see on the outside where all the hot spots are around the outside of the case here, and for the other ones as well. And we can even monitor certain spots for temperature. So on the outside of the case we have an average of about 40 degrees Celsius, and we can go right on the inside now. And move this out of the way. So I have to be quick with this. 59, almost 60 if I spin it around. So it was a little bit higher on the bottom than it was on the top. And you can see it's cooling pretty quickly already. We open this up. All right, yeah, you can see that that plate is 86. And up in the top, 71. Okay, so that plate is quite a bit higher on the bottom than it is on the top, and it's quite a bit higher than the set temperature as well. Okay, I'm going to let that run for a few minutes to get everything up to temperature, and then we'll come and take a reading. So on the outside we have average 48, P1 47, 48, and P2 just a little bit less near the front. Okay, let's open it up and see what it is inside. Again, I'm going to be really quick with this. And open. 61 and 59. Spin it around. Okay, very uniform on this one, and you can see it's cooling pretty quickly again. I've moved it over to the Eibos. We'll do the exact same thing. I'll let this steep for a little while, and we'll come back. And the final one, and actually you can see here, it says 47.3, 10% humidity, but then down here it's set to 65. So now you can really see on the thermal camera what's going on. Okay, so on the outside we have average 44, 45. On the side, 42, 43. Down near the bottom, up to 54, 55. And let's open this thing up and see what it looks like on the inside. So on the top, 53, 54, 67, 68, 73 even on the side here. So way, way too hot. 75. Okay, so we got some good information here. Definitely hot zones and cool zones with this type of filament dryer. But I want to do one more test on each of these filament dryers to really get a good sense of how much moisture they're able to remove. I think we're ready for the final test, and hopefully the most revealing test when it comes to these filament dryers. So I have these blocks of wood. I'll show you what those are for in just a minute. I have these bags of desiccant, 3 bags of color changing desiccant. Each one is measured out to exactly 45 grams. I have these little glasses. Each one I have added 45 grams of water with food coloring in it. I've also measured the total weight of the glass, and I've also measured the height. So we have a reference for the height to the very top of the liquid. So I've got each of these, 147 or 148 grams for each of these as well. And I think worst case scenario is better, so I have put PTFE tubing in each of these. So that means that we're plugging up some of those holes a little bit, and I'm going to take a little bit of filament and I put it in each one as well. So we're going to have a little bit less ventilation in those two, And I'll do it for this one as well. The reason I'm putting the wood in there is I don't want the glass touching any sort of heating element because it would heat up from the bottom and speed up that evaporation process. So I'm putting it in on top of the wood. And unfortunately for the Sunlu, I can't really see inside what's going on, but for the Creality, I can. And I'll take a bag of desiccant and put it on each one of these as well. Okay, we are ready. I'm going to turn each of these up to 65 degrees Celsius. We'll set them to 4 hours each. I think that should be enough time. This one finished first. This one says there's 4 minutes left. And this one here says there are 11 minutes left. I started them all within a couple of seconds of each other. Obviously 2 of these timers, or maybe even all of these timers, are not very accurate, but really does it matter? No, not really. So I've just turned this back on and I'll keep them going so that they all finish at the same time. So this one has just finished. We are at 14 or 15% moisture content. 27 or 28 and 52 or 51% moisture content. So there is a huge difference. And that's kind of why I wanted to do these tests as well. So let's open these up, see if the moisture content is really that critical, because I also wonder whether the calibration for the moisture readout isn't going to be bang on accurate either. For the water, the Eibos Cyclopes lost 6.5 grams. The Creality Pi, 6 grams. And the Sunlu S2, also 6 grams. These two were almost identical, 6.1 grams, 6.1 grams, and this was 6.5 grams right on. So not too different really between them, considering how big of a difference we saw on both the displays and the way that all of these do their heating of the filament. So let's open these up and we'll see if we can tell if there's any difference at all. Well, I will say that looks quite orange and not so green compared to when it went in. Let's look at the Creality. Also orange, but not as orange as these. There's definitely more green in here. Not by much. And the Sunlu. I'm the most curious about this one because that relative humidity reading was really high. So the Eibos Cyclopes did do the best job of removing as much moisture as possible from the desiccant. And then next was the Creality Pi. And then next, this is definitely greener, was the Sunlu S2. So there is a little bit of an issue with how much moisture these can remove or how quickly they can remove it compared to this one. But on the other hand, these will be far better to store your filament in for a longer period of time, especially if you can plug some of these holes up. Now I have an alternative. If you want to get your filament as dry as possible and keep it as dry as possible, find a way to get some really dry desiccant into here. You can even go in the center of the spool. And then at least when this is sitting around and the moisture that's been absorbed into the air wants to reabsorb into the filament, it also has somewhere else to go. Eibos has placed the heater directly below the filament, which I don't think is such a good idea. It really needs a baffle, or the heater can be moved into a different position because it does have the potential to fuse the lower melting filaments on those hot spots. Now I haven't had the problem myself, but I don't print much with PLA or any lower temperature materials. The other two filament dryers seem to heat the filament pretty uniformly and they don't overheat it. And even though the Creality doesn't vent the air out, it does circulate the air really well. And that means that it can more quickly transfer moisture into the air from the filament. So if we're comparing these three, I think the Creality does take the top spot, but there are many more filament dryers out on the market. So if you want to see me run any tests on those and compare them, please let me know down below. If you like what I'm doing here and you want to help this channel become a success, I have some affiliate links for products that I like and I use in my videos on a regular basis. And of course, a like and a subscribe is very much appreciated. Thank you to my patrons for making these videos possible, and if you'd like to help as well, there is a link down there below. I hope you found this video interesting and helpful, and we will see you on the next one.